Hello, guys. So, I want to change gears a little bit and explain how difficult. One of the methods in Cal 2 that we that when you get to Cal 2 you learn this method of integration. Um, that you know it is integration by partial fractions or partial fraction decomposition. And I want to be honest and say that it is one of the hardest, toughest methods that I've ever done in Cal 2. And so in this video, I want to show you guys kind of my way of thinking about it. Now, I will say this as a disclaimer, I already did the problem, and I want to be honest as well and say that I cannot explain it without literally looking at what I did. If I do it again, I might just forget how I did it. This took me a while to do, because this problem in particular is very, very long. So I hope that's okay with you guys. And so I want to kind of explain just what I did step by step, and I'll do my best to explain my method of thinking and everything like that, right? So this is the problem that we were given, that I worked on, and it is the integral of x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x dx. Now, upon looking at this, of course, this is very overwhelming. I mean, there's a lot going on. There's a polynomial on top and polynomial on the bottom, and we obviously know that the only way to integrate this is by partial fraction decomposition. Now, there are certain integrals that use partial fractions with that are a lot easier than this. So I really want to get this out of the way, because this is really hard. It's, it was a very, very long problem. So the first thing that I did here was I rewrote the problem and I labeled, this stuff in pink, the 2x cubed plus 3x squared minus 2x. And what I did was I factored out an x from this. So from this stuff over here, I went ahead and factored out an x right here. So right over here is where I factored out the x. And so what I did was I went ahead and kind of did some factoring on the side to get it to equal this for 2x squared plus 3x minus 2. So I went ahead and factored this polynomial here, this quadratic, and I went ahead and put it as this, right? Now, that is really not the hard part of this. Obviously, it's just, that's just kind of like algebra. You have to be good at factoring polynomials, quadratics, etc. The hard part begins when we have to split it up into three fractions, three partial fractions, and so this is where it gets very, very hard, very difficult, it's a lot of algebra, it's a lot of work. As you can see here, what I did was I went ahead and did it into three different fractions. Each of these is one fraction, right? So, obviously, that was my way of thinking, right? And so, of course, we went ahead and canceled out the right side, because if you think about it, these two have to have the same denominator on the left and right. So what I did was I literally got rid of the denominator on both sides. And the denominator was this, right? So I made it equal to really what the integral of the whole thing was, like literally what the integrand of this was. So then what I did was I kind of did it separately, where I put a times x times 2x minus 1 times x plus 2 all over x. So you're just basically distributing this whole thing into each of these letters and making them into the same denominator that each letter has. And then from here, I went ahead and started canceling out. So I went ahead and started canceling out the factors. And then after this was what I was left over with when I got to this part. So I went ahead and just multiplied that to each letter, like A, B, and C. That's what I was left with, right? And so, from here, and of course, I made it equal to x squared plus 2x minus 1 because, you know, this whole thing was really this over here, right? So I want to make that very clear that this entire thing was this right here because they all canceled out. So I was just left with x squared plus 2x minus 1 on the right. Okay. Now, what I did here was I went ahead and kind of did FOIL method right here. So I did FOIL method over here, and then I distributed my a value. So I got 2ax squared plus 3ax minus 2a plus bx squared plus 2bx, because I went ahead and just distributive property, right? Distributive property on all of these, plus bx squared plus 2bx plus 2cx squared minus cx equals x squared plus 2x plus minus 1. Okay, now this is where it gets a little bit tricky. What I did was, because they had, each of them had its own coefficient of x. There was x squared, there was 2x, there was negative 1. So there was an x squared term, an x term, and a constant. What I did was I separated all the x squared terms and put them together. So 2ax squared plus bx squared plus 2cx squared, and I did plus 3ax plus 2bx minus cx minus 2a equals 1x squared plus 2x minus 1. This part we really need to pay attention and be careful, because this is where you really have to make it equal to the coefficients of x squared, x, as well as the constant, right? So once I did that, I went ahead and took out the x squared term. I literally took this out and put it on the outside. And I went ahead and did, I made it equal to 1x squared, because that was the coefficient, or the leading term of my, the leading coefficient of x squared, right? So I went ahead and did that, and I ended up with 3a plus 2b, hold on guys, what was it? 3a, oh, I'm sorry, no, excuse me. I ended up with 2a plus b plus 2c equals 1. This was my system of equations that I got. This part looks a little messy. The point is, you have to make this whole thing into a system of linear equations. I can actually do this part again. So really what I did was, I had 2ax squared plus bx squared plus 2cx squared was equal to 1x squared. What I did was I got x squared times 2a plus b plus 2c equals 1 times x squared. And I divided out the x squared term. So this canceled out, so I got 2a plus b plus 2c equals 1. That is how I got this part here. So nobody's confused, right? I did the same thing for the blue part, where I took out the x term, the you know, this whole part here, I took out that x term and I made it equal to 2x, and I did the same exact thing for that. So then I ended up with 3a plus 2b minus c equals 2. Now, the way that, and then for the last part, of course, I had negative 2a was equal to negative 1. So obviously, I just did a little bit of algebra there. Got a equals 1/2, right? Negative 2a equals negative 1. You do a little bit of algebra to solve for a, get a equals 1/2. So then I went ahead and did a little bit of systems of equations there. I did elimination, of course, and this was all the work that I did to be able to solve for a, b, and c. So then I ended up with a was negative 1/2, or I'm sorry, a was 1/2, b was 1/5, and c was negative 1/10. So that's what I had over here. So now I rearranged my, because if we think about it here, I had the integral, so I had a over x plus b over 2x minus 1 plus c over x plus 2 was supposed to be was supposed to be x squared plus 2x minus 1 over x times x minus 2, I'm sorry, x times 2x minus 1 times x plus 2. Sorry if my handwriting's a little bit crappy, but... So as long as we understand that, so we ended up with something like that. And given that we already solved for a, b, and c, I went ahead and plugged those in for the following parts. So I went ahead and said a was this, b was this, and c was this, right? So it kind of makes sense, right? And now I separated them into 3 different integrals. Now, of course, what I did was, on the side, because this integral here, this integral that was right here, I had to do it separately. Did it separately, somewhere in here, yeah, right here, I did this integral separately, right? This was the whole thing of this. So I ended up with 1/2 ln of the absolute value of u. Was ln of the absolute value of 2x minus 1. Then I multiplied that to 1/5. So that's why I got this right here. And so then I did minus 1/10, and I just used my methods of integration to do, simple integrals of rational functions. And this was what I ended up with. 1/2 natural log of absolute value of x plus 1/10 natural log of absolute value of 2x minus 1 minus 1/10 natural log of absolute value of x plus 2 plus the constant of integration c. So, of course, I could have done a whole video on this and tried, showing y'all literally step by step by step by step. But it was going to take me like an hour or two to explain the entire thing. Really, to recap, I went ahead and looked at the denominator. I got my factors. I did this here. I did, solving for, doing the factoring for 2x squared plus 3x minus 2. I put that back in there, and then I did the whole thing with partial fractions. I used partial fraction decomposition. That was the whole thing of that. That was another topic of algebra. And then lastly, I just used my methods of integration. So this was 3. And then this whole thing was 2. And then, and also, actually, this whole part was also 3 because, not also 3, but that part was 3, and then this part was 4, because this was systems of equations. This part was 2, which was partial fractions. And then this whole part was part 1, which was just the factoring. So my point in this video, guys, maybe, of course, if y'all don't find this helpful, or if you want me to do a video where I go step by step on this, the reason why I did not do a video of how to go step by step on this was because it's a really long problem. In algebra, I really don't think, or I'm sorry, in calculus, excuse me, I really don't think, and I hope they don't give you a problem like that on the final exam. Of course, maybe on the homework, but not on the final. At least I hope not. Because this is a really long problem. It is very difficult. So I did do this in like a live stream on Facebook. If you guys want to look at my Facebook, it's Aussie's Math Tutoring Services. I really hope the live stream is still there, but it was a live stream of how to do this step by step, and it was the most complicated problem. So if you guys do feel overwhelmed by this, you're not the only one. This is really hard. It was one of the most complicated methods of integration that I have ever done, and I'm not gonna lie, I really hated it. But you have to have a lot of patience. You have to go very slowly, because if you kind of go a little bit fast, or if you kind of go, if you miss something, then it can, you can mess up your problem. So I really, really want to emphasize that, do not feel discouraged if this is really difficult, because it really is. But yeah, with that being said, guys, I really hope that this does help, at least somewhat, right? Or at least it gives you kind of some comfort, in a way that, you're feeling, you're not the only one that's struggling with this, right? So with that being said, guys, thank you so much for watching, and also please like, comment, and or subscribe. And also, please let me know if you have any questions. And with that being said, I will see you guys in the next video. Bye, guys.